In this video we're going to look at tilting. So tilting is whenever something is on the point of moving, so it is just about to topple basically. So consider a uniform rod AB of mass 10 kilograms when a mass of m kilograms is placed on it as shown below. So you've got your weight of your overall rod is 100 newtons, and then you've got a mass mg is placed on this. Now at a certain point mg will move. So maybe mg moves to here, so it's no longer here, and then to exaggerate, the rod is about to tilt. So what happens to your reaction at C? It is no longer in contact at C, so there will be no reaction at C. So that's a big exaggeration. But basically we're going to be looking at our questions, and it will be that it is just at the point of tilting. So C really effectively, there's a tiny little gap. You still would have your 100 newtons, and then you'd have your point D, and then your mg would be this side of it, and that would be causing it to tilt. Okay, so that's really how you draw your diagram. So you just draw it horizontally, but you would lower your C down a wee bit so you can see that there is definitely a tiny little gap there, and that's it. Okay, so that's how we look at an example here. So it just says, as a mass moves closer to the point pivot at D, the reaction force Y will get larger. So as mg moves this direction, your force here at this Y would get larger, and also your X would get smaller. So it'll get smaller until a point where it goes to 0. And then what happens at that point then? You imagine this, the plank at this time, once the X goes to 0, it basically is lifting off, or at the point of lifting off your pivot C, so then it's about to tilt. Okay, let's look at examples. Much easier once we get on to the examples. We'll just jump straight on to this one. AB is a uniform rod of length 10 meters and mass 5 kilograms. It rests on two supports, one placed at C, where AC is 2 meters, and the other at D, where DB is 3 meters. Find the largest mass that can be placed at B without the rod tilting. So basically it's on the point of tipping and no more. So it's the largest mass that can be placed at B. So on our diagram, let's just add in mg newtons. So that's your mass times your acceleration due to gravity. And we'll just say when the rod is at the point of tipping, or tilting, we'll say, point of tilting, then reaction at C is equal to 0 newtons. Okay, these questions are actually very easy, but it just really is, it's on the basis that you understand this whole bit at the start, so that it's at so you get a lot of marks for understanding really. So to do this, we can take moments about D. So basically, it's as if this force here, this whole pivot and this force was not there. That's really what you're thinking about. Don't score it out on your diagram, but that's what you have. So we're going to just put clockwise equal to anticlockwise. So your clockwise moment is equal to your anticlockwise moment. And clockwise, you're going to have mg, and that's times 3, is equal to your anticlockwise, which is equal to 50 times, and that distance in here, let's just mark it in, it's going to be 50 times 2. So 3mg is equal to 100, which means m itself is equal to 100 divided by your 3g, so 100 divided by 30. So m works out to be 3 1/3 kilograms. Okay, just want to go through that one again. So your mass of mg was put onto this end, which causes this force to get this force here at C to get a lot lower. So this force gets a lot lower, and if it's on the point of tipping, basically C is equal to the reaction at C is equal to 0. So then that means the whole system just comes down to these forces. So you've got your 50 newtons going down, your mg going down, and one's going clockwise, one's going anti-clockwise. So if it's just at the point of moving, still balanced basically, so clockwise moment equals anti-clockwise moment. So mg times 3 is equal to 50 times 2, which allows you to work it out to give you your M works out to be 3 1/3 kilograms. Okay, this example says a uniform plank AB of length 10 meters and mass 15 kilograms rests horizontally in equilibrium on two supports placed at points C and D on the planks, where AC is 1 meter and DB is 2 meters as shown. Calculate the magnitude of the reactions at C and D. So we'll jump in and do this one first of all. To do the part 1, I'm just going to redraw that diagram. And if I redraw that diagram, what I have got, I had my A, I had 1 meter, then I had my C, and that was P going vertically. Then I had 4 meters, then I had my 15 G newtons, then I had 3 meters, then I had my D, and going vertically up we have got Q, and then we had 2 meters, and then we had our B. So resolving vertically, P plus Q clearly is equal to 15G, and I'm going to take moments about C. So I'm going to do clockwise equals anti-clockwise, so taking moments about C, I have got 7 times Q, this is actually anti-clockwise, but 7 times Q is equal to my 4 times 15G, so 7Q is equal to 60G, and that means a wee bit of working out, your Q works out to be 85 5/7 newtons. So therefore, again, another wee bit of working out, your P works out to be 15G, which is 150 minus that 85 5/7, which is going to be 64 2/7 newtons. Okay, part 2 says calculate the reaction at D when the plank is on the point of tipping. So part 2, we'll just do our part 2 up here. So if your plank is on the point of tipping, so sorry, I haven't read the rest of the question. A box of mass M kilograms is placed on the plank at A. So your box is placed at A. So basically, you've now got an extra weight here, which means this force is going to go massively reduce. But if it's on the point of tipping or tilting, then that means your reaction at D will be 0. So just say at the point of tilting, reaction at D is equal to 0 newtons. Okay, part 3 says calculate the mass M kilograms of the box. So a new diagram required here. So remember, your mass has been put onto the end. The mass has been put onto your end A. So there's your A. Your mass M kilograms goes here. I still have got my 1 meter, and then I've got my C, and I've also got 4 meters to here. I then have got my point D, and you can see I've just exaggerated that and lowered my D to show that it's no longer here. So I can see here I've lowered my pivot to show that it's not touching, just to exaggerate. To do this question then is very easy. I'm just going to take moments about C, and I'm just going to say clockwise equals anti-clockwise. So taking moments about C, the clockwise is going to be, sorry I forgot to label that, it's 15G. It's 15G times 4. Anti-clockwise will be the mg times 1, so that means 60G is equal to mg. G's just cancel out, leaving you m is equal to 60 kilograms. Okay, so that's part 3 done. Question now says, and we can see it now on the screen, it says the box is now moved from A and placed at a point on the plank X meters from B. The plank remains horizontal, but now is on the point of tilting about D. So it's now tilting the other way. So it's like a completely new question. The only thing is we now know that the mass m. So we have to redraw again. So let's draw this again. This is our part 4. Okay, so that means C. And you can see I've exaggerated and I've moved my C away from the thing so as to show it's clearly not touching. I now have got 15 G newtons going this way. Here's my point D. And I needed to find the distance as a point X meters from B. So that's going to be X meters. Sorry, I'm going to move a wee bit closer this way. I'll show you why in a second. So that's X meters here, and that's for my point B. And the only reason I moved it a wee bit closer is I had to label this as this distance n is going to be 2 meters minus X meters, because remember, that whole length here to here was 2 meters, and this was 3 meters. So I'm going to do this one. I'm going to say, first of all, I'm going to make a wee note and say reaction at C is equal to 0 newtons. And then to do this question, I'm going to take moments about D. So let's just have a look at what's going on. So here, you've got your mass as well, which is 60. So 60 G newtons is going down, so that's the weight going down. It's moved to the right-hand side of the pivot at D, causing this thing here, this pivot at C, to have no reaction at all. So it's lifting off that effectively. That's what's happening. So you've got two forces to consider. This 60 G newtons, which is X, 2 minus X meters away from D, and you've got 15 G newtons, which is 3 meters away from D. So again, clockwise equal to anticlockwise. So clockwise, I've got 60 G times 2 minus X. Anticlockwise, I've got 15 G times 3, and then just do that all out. 60 G is 600 times 2 is going to be 1200 minus, and that's going to be 600 X is equal to 15 G is 150 times 3 is going to be 450, and then we'll just say 1200 minus 450 is equal to our 600 X. So whatever that works out to be, 750 is equal to 600 X, and then a wee bit of working out. 750 divided by 600 is going to be 1.25 meters. And that is us done.